Hey friends, good morning. Today is 25th of October 22. I had a good fortune of working on AUV and USVs. We have been discussing about the survey spread on the same. Today we will continue our last discussion on 1 PPS on AUV setup. As discussed, the PPS signal does not specify the time, but it is merely a start of a second, a short pulse which may vary from 3 to 7 volts. For a survey setup, especially a multi-beam survey, which has a very high update rate and resolution, we have to combine the PPS functionality with another time source that provide full date and time in order to ascertain the time, both accurately and precisely. For the time source, we have been discussing the NMEA ZDA string, though for time, there are quite many sources available. Now let's discuss the physical connection for a PPS signal. Most GPS receiver have either a BNC output or a serial output for the PPS. When we say BNC, it basically means a low speed output. And when we say serial, it means a reasonably higher speed output. Just in case we are using the BNC cable for PPS signal transmission, we have to be considerate about the ohmic value of the cable. Mostly the BNC cable come in either 50 ohms or 75 ohm impedance. For the PPS, we must use the 50 ohms impedance BNC cable, which can support a PPS transmission distance of up to 100 feet or 30 meters. Using an improper BNC cable will not only compromise the transmission distance of the PPS signal but also its quality. On a serial DB9 connector, the PPS output is available usually on pin 5 and 8, and sometimes in some systems it can be on pin 5 and 9, which basically implies that if the PPS is on pin 5 and 8 of DB9, we are sending it as a clear to send message. And if on a GPS receiver the PPS signal is through the DB9 pin 5 and 9, which means that it is being sent as a ring indicated or a RI signal. To put it in perspective, a RI signal is just a signal like our mobile and telephone which is ringing. The ringing is basically the RI signal. On various of multi-beam or other survey spread, we may mobilize a PPS adapter or a PPS synchronization box. The basic function of it is to convert the BNC signal to DB9 or vice versa and also amplify the signal. Also, we use this PPS synchronization box to create multiple PPS output for various of our equipment in different setups. Now, having a fair understanding of the hardware in use for the PPS, let's discuss about its simple settings. For the PPS, it is best to use a higher baud rate. To have a fair understanding about the baud rate, it is basically the bit frame length in relation with time. Let's take an example of a baud rate of 4800, which is 10 bits in 2.083 milliseconds. And just to put in perspective, let's compare it to a baud rate of 19200, in which 10 bits are transmitted in 0.560 milliseconds. To me, this signifies two things. High baud rate allows for a bigger data string to be processed in a shorter duration of time, and for a shorter data string, it allows basically a higher update rate, so a better resolution. But at the same time, we must be cautious that a higher baud rate put a undue strain on the processor of the computer and also the BIOS. So we have to be very balanced in our requirement of baud rate as per the data string and its update rate. All this discussion that we are having and all the efforts that we put is basically due to latency. Latency is the time from which a piece of equipment computes a value until it is actually transmitted to the computer. So whatever time string that we choose to use, like the ZDA, it has to match up with a corresponding baud rate for the desired accuracy and precision in time stamping. After having set up our PPS system, from this information provided by the TTL pulse with the NMEA ZDA string, the system driver calculates the offset for correcting the system time by basically comparing the time set on the processing system. Many times we set it up to auto correct the local time, and usually we have a module in our software for the GPS or the survey navigation system to provide us the information on the latency of the GPS receiver. There we can find the measurement of latency for the specific NMEA sentence. We will continue with our this deliberation on 1 PPS on the AUV survey spread. Hope this one was interesting, a bit informative. Take care. Bye bye. We'll see you around.